sum of the each feature value we have to add and minus from the whole set value. Finally, we are going to get 0.311. So the computational complexity of this particular algorithm is the computational cost of the constructing binary tree is well known for the general case is being order of n log n for constructions purpose and order of log n for returning a particular leaf, where n is the number of nodes. However, this results are for balancing binary trees and the decision tree are often not a balanced one. So the next algorithm which we have to use here is an CART algorithm. This is nothing but classification and regression trees. There is another well-known tree based algorithm is the CART, whose name indicate that it can be used for both the classification and regressions. Classification is not wildly different in CART algorithm. So although it is usually constrained to construct the binary trees. See, for example, a question that has three answers, say, which we are using in the previous. So it says the question about when your nearest assignment deadline. For this is having three different types of answers. So just nothing but urgent, near and none. So can be split into two questions. First one is the deadline urgent? If we say yes, then it is automatically we know it is an urgent situations. If we say no, and again we are going to ask, is the deadline near? If we say yes, it is a near. If we say no, none. So we have to find a different way to get an answer for this particular situations. So the only real difference within classification and CART is a different information measure is commonly used here. So Gini impurity is a way we are going to use it in this classification situations to find this answer. So the entropy that was used in ID3 as the information measure is not a only way to pick the feature, but the another possibility to pick feature is something known as the Gini impurity. So what is Gini impurity is a measurement used to build the decision tree to determine how features of the data set should split nodes into form a tree. The impurity in the name suggests that the aim of the decision tree is to have each leaf node represent a set of data points that are in the same class. So that there is no mismatch is going to occur here. This is known as the purity. So when if it is not available, the data points are not related to a same class, it is an impurities. So if your leaf is pure, then all of the training data within it have just one class. All the data are belong to one class, in which case if we count the number of data points at the node that belong to the class I, it should be represented in the form of n of I. Then it should be 0 for all except one value of the I. So suppose that you want to decide on which feature to choose for the split. A algorithm it loops over the different features and checks how many points belong to each class. Why? Because which are having a 1 for the particular class, those are belong to that particular class. If it is not 1, if it is 0, it is not related to that particular class. Like if the node is pure, then n of I is equal to 0 for all value of I except the one particular. So for any particular feature k, you can compute the g of k is equal to summation I equal to 1 to c and summation I j not equal to I, n of I and n of j, where here c is the number of classes which you are going to use, is like in different type of categories or in different clusters or in groups like. So in fact you can reduce the algorithmic effort is required by noticing that the summation of I ni equal to 1, since there has to be some output class, and so summation of j not equal to I, n of j equal to 1 minus n of I. Then the equivalent algorithm which equivalent formula which we are already created is reduced to g of k is equal to 1 minus summation of I equal to 1 to c ni square. Is an example which we are clearly going to identify, which is highly useful to you to find. So, if a data set D is split an attribute A into an two set of data points D1 and D2 with the named N1 size and N2 respectively. So, the Guinea impurity can be defined as the Guinea A equal to N1 by N Guinea A D and N2 by N Guinea D2. When training a decision tree, the attribute that provides the smallest Guinea D is chosen to split the particular node. In order to obtain the information gained for the attribute, we weighted the impurities of the branches is subtracted from the original impurity. So, this is what our weighted impurities that should be subtracted from the original impurity value. So, the best split can also be chosen by maximizing the Guinea gain. The Guinea gain is calculated with the help with the formula like Guinea A delta Guinea A equal to Guinea D is then original Guinea value minus Guinea D is then weighted impurity value. So, for example, in this particular table there is a data count is split in N1 N2 and its corresponding probability is like in P1 and P2. So, the Guinea impurity which we are going to find is 1 minus P1 squared and P2 squared like. So, the node 1, node 2, node 3 are different types of nodes we are going to have here, and its corresponding values are 0, 10 and 3, 7 and 5, 5 like. So, its corresponding probability values we are going to find in this particular location, and finally we are going to get the Guinea impurity values of 1 minus 0 squared minus 1 squared equal to 0 and 1 minus 0.3 squared minus 0.7 squared equal to 0.42, 1 minus 0.5 squared minus 0.5 squared equal to 0.5. Regression in trees, the new part about the chart is its application in regressions. While it might seem strange to use the trees for regression, it turned out required only a simple modification to the algorithm. Suppose that the outputs are continuous, so that the regression model is appropriate. If it is a discrete, we have to go for a classification. If it is a continuous, regression model is very good suitable for that. Based on the performance measure, we have to use the accuracy finding when we go for a classification. But at the same time, when we are go for an regressions, we have to concentrate highly on sum of square error. So, none of the node impurity measures that we have considered so far will work. So, instead we will go back to our old favorite is the sum of square error. So, based on the regressions, it is highly impressive, highly concentrated one to find the performance of the particular algorithm. To evaluate the choice of which feature to use next, we also need to find the value at which to split the data set according to that feature. Remember that the output is a value at each leaf. In general, this is just a constant value for the output, computed as the mean average of all the data points that are suited in the particular leaf. This is the optimal choice in order to minimize a sum of square errors, but it also means that we can choose to split the point quickly for a given features by choosing it to minimize the sum of square error. To minimizing the sum of square error is the excellent and efficient optimal way as we have to produce an best performance resultant. These are all some of the self-assessment questions. It is highly helpful for a student to understand how much efficiently you are going to learn this particular concepts. The computational cost of making the tree is order of log n. The decision tree is